Hello guys and welcome back. So today we are continuing with another question from the Maths Explorers group. So guys, the question that you right now see on screen is a really good question on complex numbers. So this question is kind of interesting, especially the option number D. Okay, because you can see there are four options and there are four different questions. So the option number D is really interesting, and this question will be a good experience for you because option number D is really difficult to solve. Okay. So guys, without further ado, and let me tell you this sigma CYC that you see on the screen, sigma CYC A minus B power 7, it basically means that ABC will be all added up in this A minus B power 7 order in a cyclic way. Okay, meaning A minus B power 7 plus B minus C power 7 plus C minus A power 7. Okay, so guys, nothing to say anymore. Please try your hands out on this question. I will wait for a few seconds and then start off solving. Okay, so guys, now let's move on to solving this. So first thing is, this is ABC being three distinct complex numbers, and this is A minus B past 7 in the cyclic order. So if we write down the sum, I'm changing the page. If we write down the sum, this is your A minus B power 7 plus B minus C power 7 plus C minus A power 7. This thing is equal to 0. So let's take this to be P, Q and R. Okay, so P power 7 plus Q power 7 plus R power 7 is equal to 0. So like this is our equation, and now what I'm going to do is I will try to reduce these to the powers using the relation of roots. Okay, so this might surprise you a little bit that why am I trying to use relation of roots here. So basically this will be bit interesting. Okay, so bear with me, this will be really interesting for you. So let's take some S2 to be equal to PQ plus QR plus RP, two at a time taken as a product, and S3 is PQR. So basically I can say that PQR are roots of the equation T cube plus S2T minus S3 is equal to 0, right? No harm in that. These are all taken. Okay, this is not given in the question, I have taken it for a reason. So if this is it, then actually from here we can write something, and that is we can write x cube as equal to minus s2x plus s3x. I'm sorry, not x3x, minus s2x plus s3, where x is a like value that is satisfying this equation. So if we multiply this with 1x, then 1x power, then this will be minus s2x square plus s3x. Okay, and further if we go and multiply this with another x, x power 5, then this will become s2 squared x minus s2 s3 plus s3x square. Now you would wonder where all of this came from. So basically what happened is when I multiplied this particular equation with x squared, this side became minus s2x cubed plus s3x square. Now in place of this particular x cube, I substituted this expression, and that is why this thing came out. Okay, this will be successively done a number of times, so I hope this will be clear to explain the further steps also. So next you go to x power 6, this thing will become s2 square x square minus 2s2 s3x plus of s3 square, and next one will become x power 7 is equal to minus s2 cube plus s3 square. S2 cube and s3 square, pretty symmetric anyways, times x, and I'm sorry, this will be minus of, this is nothing. Okay, I just strike this out. This will be minus of 2s2 s3 x square and plus of s2 squared s3. So this is your equation for x power 7. So now if we like PQ are all the roots, right? So if we add this particular equation for all PQR, then we will get p power 7 plus q power 7 plus r power 7 is equal to minus s2 cube plus s3 square, and this thing will be p plus q plus r minus of 2s2 s3, and this will be p square plus q square plus r square and s2 square s3. Okay, so this is the like equation we have after adding all of that stuff up. So guys, if we just look into this a little bit, then actually from this particular part you will see. Okay, I'm sorry, my voice cracked a little bit. Problem of the microphone. Okay, I'm sorry. So actually, if you see, our p q r were taken to be a minus b minus c, and c minus a. So basically, p plus q plus r is equal to 0. So actually, this whole term goes to 0. Pretty interesting, right? And if you see, this thing would come out to be minus 2 s3, and this is p squared plus q squared plus r squared, which is actually minus 2 s2, right? And this becomes 3s2 square s3. So if you add up all of this stuff, this will come out to be 7s2 square s3. So we already know that this particular thing is 0, right? So actually 7s2 square s3 comes out to be equal to 0. So if this thing is 0, and one more thing guys, because a, b, c are given to be all distinct complex numbers, that actually a, b, c are all given to be distinct complex numbers, which infers that we can't have p, q, r as equal to 0. All of them will always be not equal to 0, and therefore s3 under any circumstances will not be equal to 0, right? So for that particular case, s2 will definitely become 0. And I hope you know what S2 is. S2 is our PQ plus QR plus RP is equal to 0. Okay, so now many of you can have a very genuine doubt that why did I substitute P square plus Q square plus R square as minus 2 S2. Okay, so like really simple. P plus Q plus R whole square is equal to P square plus Q square plus R square plus 2 times of PQ plus QR plus PR. So we know this to be equal to 0, and that's why this came out to be minus 2 s2. Okay, I hope this is very evident actually, but still I explained. So guys, this thing is absolutely proof that pq plus qr plus rp is equal to 0. So if you actually like multiply pq plus qr plus rp, this will be a minus b into b minus c plus of your b minus c into c minus a plus c minus a into a minus b is equal to 0. So if you rearrange all the terms and easy multiplication, this would come out to be a square plus b square plus c square is equal to ab plus bc plus ca, which makes our option number A very correct, right? So this was a really unique method of doing this. I don't know whether complex numbers, so maybe complex numbers is a chapter where you can solve one question with many methods. Okay, so I don't know, but this was really interesting. Anyways, let's go to option number B. So actually, if we try to deduce option number B, because our PQR are not equal to 0, so like if you notice our option number B, our option number B actually contains 1 by a minus b whole square, 1 by b minus c whole square, all those, right? So basically 1 by p square plus 1 by q square plus 1 by r square, and we will use all the general results we found out up till now. So this will be p square q square plus q square r square plus p square r square whole divided by p square q square r square. So this thing would become PQ plus QR plus RP whole square minus of 2pqr times p plus q plus r. And also this thing would be whole divided by p square q square r square. Okay. So if we evaluate this like p square q square r square and stuff, this would actually come out to be s2 square minus of 2 s3, and p plus q plus r is obviously 0, right? So we don't actually need p square q square r square, okay? Because this thing s2 square minus 2 s3, this is coming out to be equal to s2 square itself. And we know something that I will show you what. And this is what we know, that s2 is 0. So s2 square is also basically 0, which means that this particular value is equal to 0. So basically 1 by a minus b whole square, and because this is 0, your denominator doesn't at all matter. So 1 minus a minus b whole square, sorry, not 1 minus, 1 by a minus b whole square plus 1 by b minus c whole square plus 1 by c minus a whole square is equal to 0. Option number B is also correct. Okay, so that's the option number B, and let's move on now to option number C. So guys, option number C will actually be the easiest because we have already found that S2 is equal to 0, right? So if S2 is 0, if we substitute this thing back into our equation, that t cube equation or x cube equation, whatever, variable doesn't matter, right? So whatever equation it is, if you substitute that S2 equal to 0, then you will actually get x cube is equal to S3, right? And this is for x is equal to PQR, because PQR are the roots. So any constant value this is equal to doesn't matter. The thing that matters is PQR are all equal amongst themselves in the cube. So P cube is equal to Q cube is equal to R cube, or A minus B whole cube is equal to B minus C whole cube is equal to C minus A whole cube. So option number C is also correct, right? Okay, so that's it, done till option number C. But now the real game starts, which is with option number D. Okay, this is actually the real, like, really good option in this particular question, because these options I hope anyone can do. But option number D will actually stop you. So guys, like, option number D tells us something like this, that the if small ABC form a triangle ABC, like the complex numbers small ABC are the vertices of the triangle capital ABC, then the sum of lengths of altitudes from any point inside triangle ABC will be an expression is given. So guys, like, first thing that I would like to tell you, like, just look at what I'm writing. Okay. So, like, very much pay attention to this particular option, because this is a really good question. Okay, this particular option actually makes the question a really good one. So guys, this particular thing, because we have p cube is equal to q cubed is equal to r cubed, from here we can actually write that mod p, I have to put a mod because we don't know about the sign, is equal to mod q is equal to mod r, right? So this is the like equation, mod p is equal to mod q is equal to mod r. So if this actually the three complex numbers are equal, that is mod a minus b is equal to mod b minus c is equal to mod c minus a. This actually means that these are the actually side vectors of the triangle, right? Side complex vectors of the triangle. If I take the triangle something like this is your a vector, this is your small b vector, and this is your small c vector. Actually complex numbers and vectors are very much interchangeable because inequalities work in a really similar manner. So for our simplification, if we want, we can treat complex numbers like vectors and do that will make our simplification easier. Like if it makes, we can obviously do that. Okay, there is no harm. So actually if this is the case, it means these are the side vectors of the triangle, and they can be obtained from one another by rotations of 120 degrees. Why? Because, like, very obviously, triangle ABC is an equilateral triangle. Now, this is an inference, but sum is not still over. This inference was important because from here actually we will try to derive something. So, if for an equilateral triangle of side length, all the side lengths are equal. So let's say we take it to be mod a minus b only. What is given in our question, right? S equal to mod a minus b. Then the altitude length. Okay, this length of the altitude, I know, hope all of you know this. This will be equal to root 3 by 2 times the side. And area of the equilateral triangle. This also you should know. This is very basic stuff taught in your class 8th and 9th advanced geometry. Okay. Not very much asked in JEE nowadays. Like JEE is really ignoring geometry, but they shouldn't. Okay. Like geometry is a really beautiful thing. Maybe I will try to bring some questions on geometry also if I find, because geometry is something that JEE should ask, because it is not in 11th and 12th, but it is in our preliminary syllabus, and mathematics has an important part of geometry everywhere, right? Anyways, let's continue. So area of the equilateral triangle is actually half times S into d1 plus d2 plus d3. Okay, so now you will ask, what are these d1, d2 and d3? So actually d1, d2 and d3 are your perpendicular distances from any particular point. Okay, and S is your side length. So this is actually the area of the triangle, and one more area of the triangle that we all know for equilateral is root 3 by 4 S squared. So if we equate these two, we will actually get a d1, or rather write this as dA, dB and dC. Okay, that would be better. dA, dB and dC. So dA plus dB plus dC would actually become root 3 by 2 S if you equate. So very like, if we want to find out our this thing, we have to multiply root 3 by 2 times S. But now to express this in terms of area, that is the challenge, right? I mean, not an area. To express this particular term in terms of complex numbers, that is our challenge actually. Because what they have asked is the sum of lengths of altitudes from any point inside triangle ABC. So you have to convert this thing into a complex number form. Okay, so let's try to do that. Okay, so if we actually see one thing, that dA plus dB plus dC here in particular, it is actually equal to the height of the altitude, which is h. So if we find out the height of the altitude, then our work is actually done, right? So let's focus towards that. So to find out the height of the altitude, say this is maybe the altitude length h. To find out this particular height, let's take two vectors. Okay, u vector, which is your b vector minus a vector, and I'm taking another vector w vector, which is c vector minus a vector. Two vectors. Okay, so these are the two vectors, guys. And so if we okay, now if we want to find out our perpendicular distance, or rather the, what should I say, length of the altitude. So for that particular thing, actually it is the perpendicular distance, although in my diagram I drew it from A, but you can consider it because the vectors are taken in that way, right? So perpendicular distance from point C to line AB. Okay, so if this is it, like to find out, now this will be the most interesting part, how to find out. To find out this, I will take the fraction w vector by u vector. Now, okay, wait. Do one thing. Right now, don't treat this like a fraction of a vectors. Treat it as a fraction of the complex numbers itself. Okay, w by u. Consider these are two complex numbers. So I can write this as wu by mod u square. Right? No harm, I hope. W by u is equal to wu by mod u square. So after this step, okay, guys, just be careful, like you can confuse here. This is something that I am doing, treating like I am trying to convert u vector here. Okay, you can put bars on w and u if you want, but actually here these two I am treating, they are complex numbers, but I am treating them like vectors. Okay, this might be a little confusing. After this step, I will take the imaginary parts on both sides, imaginary part of this thing, and also would be equal to the imaginary part obviously of this thing. So imaginary part of w u vector by mod u vector square. Now you would have a question like why the imaginary parts are equal. Very basic, simple, because these are c minus a, b minus a type, so real part actually won't exist. Or if you want to take a generalized case also, you can take, okay, you can consider, say, because we are drawing it from c to ab, you can take c as the origin if you want, but any way you take it, imaginary parts will come to be equal. Okay, if you want, you can test also with any three random complex numbers. So guys, after this, if we multiply this with mod u, like I am actually doing all of this from my mind just to bring out that thing we want, the purpose, okay? Because this is not something conventional. I am doing this because I want out to bring out the answer, okay? And I'm sorry, mod u also, and this here also put a mod. Imaginary part also would be in mod. This thing would be equal to mod of imaginary part of wu, which is whole divided by mod u. Okay, basically I took a mod u from here to here. So right now, if we see this thing, this will actually become equal to like mod, not only mod, imaginary part of wu. Okay. Okay. So guys, actually what you should do is just ignore this step. Okay. Like I should not write this because determinant with complex numbers is not very much in your syllabus. Like sums can come small, but its application with vectors is not in your syllabus right now. So I should not go into that. Actually, this step will be very self-sufficient. Okay. If you notice this, like this particular part, the RHS, this is actually is nothing but the perpendicular distance of C to AB. You can perfectly test out if you want. Okay, actually I also had tested out by taking w as some x1 plus I y1, and like sorry, not w, yeah, w as x1 plus x1 plus I y1, and u as x2 plus I y2. Okay, I had taken both of them and actually tested out, and all the conditions were matching. So you can do the same. I haven't done because there is a little bit crisis of time. The video will get too long otherwise. Okay, you can test if you want, it will definitely come. So guys, actually this thing is the thing we want, and so our quantity will be this. And very much mod u is a minus b, and this is imaginary part of w by u. So c minus a by, I guess this will be b minus a. Okay. So guys, I hope the sum is done. And obviously you can put a mod over this also. And I guess not put a mod, it's already there. I forgot to put, you should put. Okay. Anyways, this was a little tedious and maybe I tried my best to explain. I hope you have all understood this. So, conclusion is option D is also correct. Okay, so correct options are A, B, C, and D. Anyways, guys, that will be the end for this video today, and I hope you had a great time solving this question because this is a really nice question and I enjoyed solving this. Okay, so guys, that's the end. If you have any doubts, do write down in the comment section. Any recommendations also do come up, and if you have liked my channel, do like, share, and subscribe. Also do come out in my Telegram discussion chat because we are having really fruitful discussions about your exams there. Okay, so that's it for today guys, and thanks for watching.